So yeah, so this is it. So chapter 12, we have 4 sections, 12.1, 12.2, 12.3, and 12.5. And then that's it. After that, and that'll be like this week and next week pretty much, is the end of new material for you. So it's kind of nice. People usually, the trig, I'll start from the ground floor, and you've all had trig. So most people find the trig stuff pretty easy because they've already had it. So that's kind of nice. You've only got this week and next week pretty much for new pre-calc material. And then it's just review from there.
And this is 12.1?
This is 12.1. Yeah, it's not on the screen, is it? So this is 12.1.
Why is that 4 excited?
Yeah, it's like 4. Everybody seeing that?
The 4 is really excited.
Yes, with enthusiasm. 12.1, and what it is, it's intro to sequences. So chapter 12 is all about sequences and series, which basically means a list of numbers. Because this is basically the last algebraic topic so that you've seen everything for calculus. This class is kind of a catch-all everything as you get ready for calculus. So we've done matrices and I won't list it all. We've done everything. All we got left is sequences and series. Calc 2, you go deeper with sequences and series. So this is to lay the foundation so that you're comfortable when you hit Calc 2. Next semester for Wendy, sequences and series.
I'm scared.
All right. So 4, yeah. So what's with that 4 being all excited? 4 with the exclamation point. To some of you, it's called factorial. And what does it mean? Do some of you know already?
They're golfing.
It's happy.
Yeah, 4. That's right. It's happy 4.
I was just laughing.
Nobody knows? You seen this before?
I see it on my calculator, but
Yeah. 4 times 3 times 2 times. It means multiply 4 all the way down to 1.
Oh. N minus 1.
So it's what?
N minus 1, right? The number that we start with minus 1.
Yeah, just keep going down by 1 every time, right? And just go all the way down to 1. And what's the answer? 4 times 3 times 2 times 1?
12 times 24.
24.
Oh, okay.
There we go. Abdul, did you, when you were a kid, did they let you have a calculator? And when you're doing math?
Yeah.
Did you use calculators? Or
No. I have never used it.
Exactly. Do you know how? Do you know? All right. So, so 24. 4 factorial is 24. You almost laughed when I asked you if you had a calculator as a young man. No, nobody does. I know. All right. Having said that, let me show you how to do this on your calculator. So there is a button, and we'll use it because we don't need to. I mean we could do it by hand. So why, if you can, why bother? So the way you do 4 factorial is you hit 4, and then hit that math button, and then go across to the PRB. I think it's 3 times across to the PRB menu, probability submenu, and go down, and you'll see the exclamation point there. Do you see that? So then you can just put this in 4 factorial. You don't need parentheses or anything. Just 4 factorial, 12 factorial, divided by 8 factorial. Hit the buttons, you get some big number. No parentheses needed. 285,120.
4 exclamation point.
Yeah, 4 exclamation point.
12 exclamation
12 exclamation point divided by 8. Probability menu. Yeah, it's
exclamation point.
yeah, no, this is on the graphing. I'm telling everybody on the graphing calculator. Yeah, other ones it's different.
Oh yeah, my
Everyone would be a little
scientific
different.
calculator won't do it. It does not.
No, I'm sure it will. It's just somewhere hidden.
No, I see the exclamation point, but it wouldn't let me do that.
Well, I don't see it here, Rachel.
Yeah, no, I was just like, it said math, and I didn't hear the calculator part, calculator, so I was just like.
Yeah, I don't see it. I'm sure it's somewhere that I can't find.
It might be under called something different, yeah.
All right, we good on that? You guys getting that answer okay?
Where's the exclamation?
On the calculator? Or you could do it by hand. Be big, though.
Where's the exclamation point?
Annoying to do by hand.
Where is it?
Under math, hit math, and go across to the probability menu.
Wait, I'm having cookies.
And then you'll see it down there below on the... Everybody find it on the probability menu?
No.
Under math, hit math, go across to the PRB menu. All right, the menu's at the top. Go over to the PRB menu, and you'll find the exclamation down there. And so you type the 4, do the exclamation, then the 8, or the 12, then the exclamation, divided by 8, exclamation.
So
So you're inputting the symbol.
All right, I'll move. All right, so there we go. So what is this? So this is basically a formula, and they just want you to plug in 1, 2, 3, 4, 5. So this will be real easy for you. So just take that formula and plug in for n. N is like the x, you know. Just plug in. So I'm going to plug in 1 here and 1 here. So I'll get 1 over 1 plus 5, 1/6. Then plug in 2, 3, 4, and 5. That good? So go ahead and keep going.
The history of mathematics, like a god.
So put it in there. 2 over 2 plus 5, 2/7. Is that good? Plug it in 2. And then plug in 3. 3 over 3 plus 5, 3/8. Can I just go etc.? The last one you got to reduce 5/10, make it a half, right? 24 here, they're giving number 7 here. They're giving me a list. So we're playing the game backwards now. They're giving me the results. They're saying, hey, there's some formula. And we plugged in 1 and we got 6. And we plugged in 2 and we got 12. And we plugged in 3 and we got 18. And we plugged in 4 and we got 24. So what is that? So what is the formula that we're plugging in? So we're doing these problems backwards.
A7 equals 6 times n? Or a sub 6? No. A7 equals 6 times n.
Wait, I can't even write the word here. I don't know what's wrong with my thing. All right, formula. Yeah. So what formula are we plugging into? What can you plug 1 into, get 6? 2 into, get 12? It's just 6n, huh? We're just plugging into 6n, aren't we? See how that works? Because if you plug in 1, you'll get 6. Plug in 2, 6 times 2 is 12. 6 times 3 is 18. Good so far? Now that's not the actual question. I'm giving you an easier version. Now let me put in what it actually is. Then they're going to say, okay, not only 6, 12, 18, 24, but we want it to go plus, then minus, then plus, then minus, etc. We want it to alternate back and forth, plus and minus, plus and minus. That's weird, huh? What's going to do that?
Negative number.
Yeah, negative number. But why would it change back and forth?
Because the bigger one's going to be negative. I don't know.
You seen this before? It's something they do a lot. If you go into higher math and science, computer science also, they use this. It's a common tool for changing signs. Once you've seen it, you know it. It's basically minus 1 to the n power. Do you see as you put powers up there, that'll change. Negative, positive, negative, positive. You know what I mean? Like, think about what's negative 1 to the 1? Well, it's negative 1. And what about when you plug in? So if you plug in n equals 1, you get negative 1. If you plug in 2, you get positive because negative times negative.
For even numbers, you'll get positive.
Right. Plug in 3, you'll go back to negative, etc. You see the idea? It's just going to change negative, positive, etc. That's the trick on that, right? It'll just keep changing signs, although I can't write it for some reason. Anyway, but careful, that's not quite right, the right answer, because you need to start it right. Ours starts with positive, then negative, then positive, right? So this one starts negative. So that's not quite right. How do you make it start positive? You got to do a little change.
So the negative
N plus 1. Because now this will be 1 plus 1. This will be minus 1 squared. Start positive, huh? And this will be 2 plus 1. Minus 1 to the third, which will now be negative. And this will be 3 plus 1, which will be fourth power, will now be positive. Do you see how that works?
Negative 1 squared plus 1? Or, negative
No.
squared. Okay.
Negative 1 to the third. Yeah. Does that make sense? We're adding 1 to the power. Right? So whatever the n is, just add 1. And so that'll make it start positive. So whenever you see this negative, positive thing, if you're going into higher math and science, it comes up a lot. Just know, oh, they just threw one of these -1 to the n or n plus 1, depending on how you want it to start. Start positive or start negative.
You have it to the power of n minus 1.
Yeah, and that's the same thing. N plus 1 or n minus 1 will work exactly the same. Yeah. Good there? I'm going to go back. We only got time for one more, looks like. So they're saying, okay, comma, ... Name that tune, name that formula. They're saying there's some kind of formula. We plugged in n equals 1. And we got 1. We plugged in n equals 2 and we got a third. We plugged in n equals 3 and we got a ninth. We plugged in n equals 4. We got a 27th. What in the world is that formula?
So, 3 times 1/3.
So how about I let you... So you think, I think it's 3 times, I'll just do something. 3 times n plus 7, whatever. Okay, it's not. But in the trying, you'll learn so much. So if you think that's what it is, I'll just say, I think it's 3n plus 7. Well, then try it. Plug in, what do I mean by try it? Plug in 1, see if you really get 1. Plug in 2, see if you really get 1 there. So I plug in 1, what do I get? 3 times 1 plus 7, I get 10. No, I'm not even in the ballpark. Right? That was just a crazy idea. But anyway, I just wanted to show you what it means by checking. So try writing down a formula, plug in 1, 2, 3, see if it's working. If it's not working, see how you might tinker with it to make it work. You've got 1 minute. Now we're out of time. So normally...
6 times 1/3.
Does anybody have an idea? Like, what should we do?
It's an incrementing series, but I don't know how to say that.
So, any ideas? Certainly it's got to be involving a 3, right?
Yeah. It's going up by 3 on the base.
3 to the negative n plus 1.
3 to the negative n plus 1. That's pretty fancy.
Oh, is it
3 to the negative n plus 1.
3?
3 to the negative n plus 1. How can we test if that's right?
You could plug in
Juan's 1, right? Juan's got a theory. Let's try it out. Plug in 1. What do you get?
It's just 3.
3 to the negative 1 plus 1. What's that? 3 to the 0? What's anything to the 0 power?
1.
Juan's rolling so far. He's got the first one.
I think it's 3.
Right? We plugged in 1. We got a 1. That's what we're supposed to get. But let's try 2 now. Plug in 2. 3 to the minus 2 plus 1.
Oh.
What's that?
1/3.
3 to the minus 1. What's the negative power do? Look at 1 go. One more. Plug in 3. 3 to the minus 3 plus 1. 3 to the minus 2. What do you do with the minus 2? Flip it and then 3 squared. Look at that. It's cranking. Good job, Juan. How'd you come up with that?
Just write stuff and test it.
Yeah, I mean, it's true. That's how I learned too. I just wrote stuff and tested. Yeah, basically this is like a 1/3, right? So this is 3 to the 1, 3 to the 2, 3 to the 3. See the pattern? So it's like 3 to the n, but you got to do minus 1 because the first one's a 1, so you plug in 1, you get. So that formula is the same as Juan's. Juan wrote it in a very fancy way. These are 2 ways to say the same thing. I think Math Excel knows they're both the same. Do you know they're both the same? Those are both the same. They might look different to you. I'm already over time, so I'm going to have to